video. Today we are looking at question 701, insert into a binary tree. The way we'll be approaching this problem is by using recursion. We'll be looking at a node value, and based on the value, if the value is greater than, we know that we would have to move to the left of the node. If not, we would have to move to the right of the node. So based on the value, we will call this method that we have already, insert into BTS, recursively, and create a new node when it's necessary. So let's jump right in. So what's the first base case? The first base case that we need to cover is if root is equal to null, you would just create a new tree node with the value that's given to you, val, and you would return it as is. If not, you look at the current value, right? And if the node is greater than the value that we have to increase, we know that we have to go to the left side of the tree. So what we would do is we would say root.left would be equal to insert into BSC, but you'll call that on the left. Root.left, and then you'd call it by value. If not, you'd move to the right. So if value is less than, you'd move to the right of the tree. So it would be root.right would be equal to insert into BSC and then root.right with the value. So what exactly does this part of the code mean? Like these two lines. This means that you will keep going down the tree till you actually find that piece of the node which is relevant for us, which is most important to us, right? So that way, as soon as we get a space, we know we're in the right spot, we will reach this line of code, which means, so for example, in this case, like example 1, you have 4, and then you have 7, and then when you reach 7, we would have passed on the left node, but the left node is null. So this condition would be true, and you would apply the tree node there, and you would return back that value. So that's how it works. And then in the end, you would just return the root. Awesome. So let's run this part of the code and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the solution. The time complexity of the solution is O of n because there's a possibility that we have to go through all of the nodes before we actually need to reach a spot where we can insert the node. But the space complexity would be O of h. And the reason why it's O of h is because here we would be considering the stack space, the recursive stack space that we need to actually keep a track of all of the calls that we've made recursively. If not, we're not using any additional data structure. So if you're not counting the stack space, it would still be O of 1. Awesome. So if you have any questions about this problem, please let me know in the comments below. And please don't forget to subscribe to the channel and like this video. It really motivates me to create more videos. Thank you so much, and I'll see you all in the next video. Peace.